So for this first one, what do you have to do? You could divide by 8, but it's safer because it's this one over here that doesn't work.
Right.
So it's safer to multiply through by the 8. So 8 times 2x, 16x. 8 times negative 7, negative 56. Now what are you going to do? Add 56. 16x equals 80, and then divide by 16. X equals 5.
I still got 5 at the end of it.
Yeah. And you would for that one, it would work.
Yeah.
This one, it doesn't work so well.
So you have to do the multiply.
Yep. So 5 times 3x,
I guess that's what I missed.
15x. 5 times 1, 5. Then we got the 2x yet.
17x plus 9.
So we combine the 15 and 2 to make 17x. Plus 5 equals 56. And then subtract 5. 17x equals 51. And then divide by 17. X equals 3. And of course, on all these, I can go back and replace x with 3 and work it out, and I should get the same number on each side, right? Now, what you were saying, Nate, about dividing by 5, you could divide this all by 5. But remember, when you multiply or divide, you have to do it to every digit. So you divide by 5 here, you'd have to divide this by 5 and get 0.4x.
That's where I was going to ask you.
And this would be 11.2, and it gets ugly. But it's easier if you just multiply all the way through. Yeah.
Sorry.
That's okay, it happens. Just don't let it happen again.
I try not to make it a habit. Well, I came in a couple minutes later about that. I try not to do it because it's an easy habit to form.
Yes, once you form it, it's hard to get out. So this one here now, here's one where you could divide by 5, just like you were saying. Now, don't write this down because I'm going to show what you would do. If you divided by 5, you could divide by 5. That digit's getting divided by 5, but you'd have to divide this by 5 and this by 5. So you get 7x minus 4 plus 1 equals 18. That'll work. But it's safer to multiply by the 5.
What do you call that?
Distributing.
Yes, that's what it is. Okay.
5 times 7x, 35x. 5 times negative 4, negative 20. Plus the 5 equals 90. And then negative 20 and 5 make a negative 15. And then add 15. 35x equals 105. And done. Divide by 35. X equals 3.
That's a lot easier than doing the decimal. All that fun stuff that we left behind.
How about something like this? Distribute. So 2 times 5x, 10x. 2 times negative 4, negative 8. How about this one? Yeah, you treat that as a negative 1. We're going to distribute the negative 1. So negative 1 times 3x, negative 3x. Most people get that part right, but this is the part they miss. Negative 1 times 2, negative 2. A lot of people put that in as a positive 2. They screw that up.
So the 7x minus 10.
Sure. Perfect. 10x and negative 3x is 7x. Negative 8, negative 2 is a negative 10. And then add 10. 7x equals 14. And then divide by 7. I may have done them a few times before.
It always come out to like
I do have some of the longer.
5. It's simple.
Well, as long as you know what number x is in your head, it's not so hard. Some of these longer ones I do have jotted down just because I come up with them on the fly, and I think that's a good one. I should use that again next year, so I jot it down on the little lecture note. Something like this. Shoot 7, okay, 7 times 2x. 14x. 7 times negative 5. Negative 35. Negative 2 times 3x. Negative 6x. Negative 2 times 1. Negative 2. Nothing to do on the right side. Over here, what am I going to do? 14 and negative 6x make 8x. Negative 35 and negative 2? Negative 37. And over here I got 3x plus 13. Now I've reduced or simplified, combined everything I can on each side. But there's still an x on each side, so I have to get rid of 1. Take the smaller one's the 3x, I'm just going to subtract 3x. 8x minus 3x is 5x. Remember, when we add or subtract, we only have to do it to one piece on each side.
You have to do the x first.
Yes, you should do the x's first. You should always get it down to where the variable only appears once before you start doing anything else.
Is there some equations that it makes a difference? Or is
It just saves confusion. I mean, there are most equations you can do it the other way, but it can get confusing. How do you know which side to move things to? Until you get, once you've got the x, so it's only one x or one variable that appears only once, well, then you know what you have to get rid of. You got to get rid of everything else that's with that variable. Until you know where the variable really is, how do you know which ones to get rid of? So now we're going to do what? Add 37. So 5x equals 50, and then divide by 5. X equals 10.
Good. I found the highway. Yeah, it was left at the stoplight, follow 8. Luckily at the stoplight there was a road transition. 8 and 53 right, so they both turn left.
One for you guys to try in your notes. Okay, so where do we start? Distribute. 3 times 5x.
15x minus 3.
3 times negative 1 is negative 3. Yep. Next.
Distribute negative 2. Distribute negative 6x minus 8.
Perfect. Negative 2 times 3x is negative 6x. Negative 2 times 4 is negative 8. Now I'm going to stay on the left side and just combine stuff. Then I'll move over to the right side. So over here, what else can I combine? 9x. Okay, so now we can't combine anymore on the left side, so we're going to go to the right side. So 5 times 2x. 5 times 7 is positive 35. Good. And then 2 times x. 2 times negative 3. Yep, negative 6. And we have the plus 2 there yet. So now we're going to combine. 10 and 2 makes 12x. 35 minus 6 is 29, plus 2 is 31.
What I did there was, just to make it easy, and correct me if I did it wrong, but I just combined negative 6 and 2 to make negative 4 and then subtract negative
that works.
35.
Add a negative 4. Yeah, you're technically adding a negative 4 to 35, but yeah, that works.
Yeah, adding negative 4 to 35, but since they were right next to each other, I just combined them.
That does work. Yep. Now we're going to get rid of one of the x's. We're going to get rid of the smaller one, which is the 9x. So we've got negative 11 here equals 3x plus 31. And then you subtract the 31. Negative 42 equals 3x. And then 5 by 3. Negative 14 equals x. Are we having fun yet?
I don't know. Is the next step decimals? Because if it is, I better break out my sombrero. Oh, fraction. Oh. Oh, don't make it common denominator. That'd be too easy.
Fractions are now your friends. Remember that. This equation here is exactly the same as if I had like 5x minus 2 equals 38. What would I do on this equation here to solve it first? I'd add 2. Over here, I'm going to add 1 3/4. So that's gone. I've got 2/3 x here equals 4.5 plus 1 3/4 is 6 1/4. Now, you can do that on your calculator. You can do it out longhand, however you want to do it. I'm going to trust you guys can add fractions at this point. What would be the next step over here? I would divide by the 5. So over here, I'm going to divide by 2/3. A fast 5. So x equals 6 1/4 divided by 2/3. Anybody?
4.5.
9 3/8. So 6 1/4 divided by 2/3. This becomes 6 times 4 is 24 plus 1 is 25/4. This is going to be times 3/2. So it's 75/8. 8 goes into 75 9 times with 3 left over. See how simple that is?
Are you sure the Texas Instruments isn't named after you? Calculator.
I've done this stuff a few times before. You got to remember, there's patterns. Or you might have 2.8x minus 3.2 equals
We had no trouble writing down the kilometer the other day doing the Bohr scope. Luckily, we had that in class, so we kind of knew what we were looking at.
oh sure.
So they had 3.2.
Add 3.2. So 2.8x equals 7.6. And then divide by 2.8. X equals
2.1.
2 point.
I forgot my calculator today. I forgot my calculator.
7142857 approximately. How's that?
Oh, I know what the next step is. He's gonna put pi in there. Just to really
Pi sounds good.
Just to really assert pi. He's gonna pi.
How's about something like this? Now remember, think about what's been done here. X has been multiplied by 3, then the 7 was added, right? That all had to happen first. The top has to happen first. Then it was divided by 4. Well, to take it apart, we must first multiply by 4.
Wouldn't you multiply the top too?
Nope, multiplying by 4 gets rid of this piece. That divides the whole top.
What goes in parentheses?
That'd be a little different. Now, I'll come back and I'm going to show you a little bit on that in just a second once we finish this one off. What's our next step? Subtract 7. 3x equals 21, and then 3x divided by 3. That's equals 7. The other option you could have had up here is distributing. Could have divided each piece by 4. 3x divided by 4 is 3/4 x. 7 divided by 4 is 7/4. Equals 7. And then we could have subtracted 7/4. So 3/4 x equals 5 and 1/4.
So
Then you could have divided by 3/4. X equals 7.
yeah. So you could just divide out or multiply out the factor.
Yeah, it's technically it's 1/4 times what's up there.
Gotcha.
Yeah.
Okay. Rather
Now, just like we saw with the parentheses, if we had something added like here, then we would have to divide it out. I don't hate you guys enough to give any problems like that, just so you know. But I might give you something like this.
Our shirts do say automotive, right? Because I bet for the architecture and woodworking class, you would do that.
Oh yeah, definitely. What about here? What do I have to do? Times 7/8 cancels that out. Times 7/8 over here. So this leaves me with just 2/3 x minus 1/4. 7/10. And then add a quarter. Two-thirds x equals, this is 14/20. This is 5/20. That's 19/20. And then divide by 2/3. That cancels that out. Gives me x equals 1 17/40.
Please don't think we're stupid if we wait for you to give us the calculated answer.
No, I don't. Any more than usual. Careful, Dionysius. Looks familiar, right?
How can I give him a headache today?
Till I do this. Oh, trust me, I know how to give you a headache every day. What am I going to do with that? Try?
Combine the fractions on the left. So it would be
Yeah, that would work, but that's really nasty.
2x over 6 equals 7x plus 4 over 36.
Whoa. 2x over 6, where are you getting that?
4x minus 2x.
Oh. They don't have common denominators. Think in terms of common denominators. I got 15, 9, 6, and 30. What is the least common denominator, least common multiple of those? You're thinking greatest common factor.
Least common multiple would be 6. No, it would be. Because 15 only goes to 3, 5.
Well, 15 goes into 30 and 6 goes into 30, so we don't have to worry about those. So it's the 30 and the 9 we have to worry about. What's the next number that both of them go into? It's going to end up being 90. Because 30, 9 does not go into 30. 60, 9 does not go into 60. 90 would be next. 9 does go into 90.
What does 15 go into 90?
15 goes into 30, so it has to go into 90. Goes into 96 times. 6 goes into 30, so it has to go into 90.
Oh, yeah, 15 times 2 is 34.
Yeah. So I'm going to multiply this whole equation by 90. So now this is just a single digit here. So it's 90 times that. So I'm going to make it 90 over 1 times the 4x plus 3 over 15. Now the first thing I'm going to do is I'm going to cross cancel the 90 and the 15. This is 1 and this is going to be 6. 15 goes to 96 times. Now I'm going to put parentheses around this. So it's 6 times 4x is 24x. 6 times 3 is 18. Now this one's a little different. This is a negative here. So it's going to be 90. I'm going to multiply it. 90 over 1 times that 2x minus 3 over 9. But it's a positive times a negative, so this result is going to be negative. So I'll put the negative with the 90 for now so I don't lose track of it. So times, I'm going to cancel out the negative 90 and the 9 gives me 1 and a negative 10. Put parentheses around this. What's negative 10 times 2x? Negative 20x. Negative 10 times negative 3, positive 30. Do you want me to pause for a second? Let you catch up, Nate? Or? Okay, I'll give you a second. Yeah, it looks really ugly and intimidating, but it's not as horrible as you think once you get into it.
And then 1 to 1 cancel. Then be minus -90.
Yeah, and the reason I put a negative 90 there is because there was a negative here.
9 and 90.
Cancel. 1 and negative 10.
Negative 10.
And again, the negative really isn't with the 90, but there's a negative here and it had to go somewhere, so I put it with the 90.
Negative x plus
30. Perfect. Then the equal sign, now it's 90 times this one. That's going to be 90 over 1 times 6x plus 4 over 6. I will cancel the 90 and the 6, gives me 1 and 15. I'm going to multiply this out. 15 times 6x is 90x. 15 times 4 is 60. And then I still have 90 times the x over 30. So 90 over 1, x over 30. I'm going to cross cancel the 30 and the 90 to get 1 and 3. 3 times x is 3x. Now I'm going to combine over here. 24x and negative 20x is 4x. 18 and 30? 48. Over here, 90x and 3x? 93x. Isn't that a radio station? And then I still have the plus 60. Then what? Subtract 4x. Get rid of the x's. So I've got 48 equals 89x plus 60. And then? See, and this is why you want to get the x's together first, because, yeah, I was tempting to subtract 48. But now that they're together, I see the 48 needs to stay there. It's the 60 I have to get rid of, right? I subtract the 60. Gives me a negative 12 equals 89x. Then we divide by 89. Now I could divide negative 12 by 89 and get negative 0.13 whatever. But what's wrong with just saying negative 12/89 equals that? I can leave it as a fraction. Remember, division is a fraction. Fraction is division. Yep. It's actually more exact because if you do a decimal, you can get a repeating decimal that never stops here. It's really ugly. So it's going to be rounded off if you do that. So if you leave it as negative 12/89, it's exact.
That's an acceptable answer on the test.
Yep.
I think if it's
Yep.
division like that.
Yep. So either this way or as a decimal, either one would be good.
So we can't do 15 divided by 3 as an answer?
You know,
Let me introduce you to my tack hammer. I think I gave you page 253 yesterday.
yes.
Exercise 6.3.
Yep.
I'm throwing it out there again just for
Same thing.
fun. And then page 258. Exercise 6.4. 1 through 25 is the odd. Other ones with the fractions and decimals in them.